now?
Yes.
Okay.
Please go ahead.
Okay. Let's continue. And this is the C-band and high frequency spectra. This picture shows us the world's frequency band or spectral distributed. We can see the 3.5 is the main 3.5 gigahertz is the widely used frequency band in the world. And the second is the millimeter wave. Millimeter wave used for the supplementary. And the first batch of 5G used like the American USA American use the also use this low frequency band. You know, actually the USA US the majority part will be used the millimeter wave. Majority part use the millimeter wave. Because the C-band is occupied, it's not free, can't be used. And also, nearly the American announced that they use the low frequency band, low frequency band for the coverage, and for some other country, like the European Union, like Japan, like China, like Korea, they will deploy this in 3.5. This one, 3.5, where use this frequency band. And the second use the millimeter wave. This is the words. This is about the frequency allocation of the word, different country. And this is the spectrum. 5G spectrum will be ready. Like China, like Middle East, Europe, and America, and Brazil, and Australia. And this is China's situation. This is China's situation about the frequency band. You know, in China, there are three main operators. One is China Mobile. China Mobile is the biggest operator in China, and China Telecom, and China Unicom. This is the second operator, and this is the third operator. And China Mobile get the 2.6 gigahertz. 0.6 gigahertz frequency band, and China Telecom and China Unicom get the 3.5 gigahertz. They are from 3.4 to 3.6. In China, you know, these two operators will be deployed the 5G base station together. They make sure the base station, because these two operator is not didn't have enough money to invest the 5G base station. So they will put together, they will deploy the 5G base station together to reduce the cost. But for our mobile, China Mobile, it's the biggest operator in China. This operator have enough money, so they will deploy the 5G base station independently. And China Mobile also get the more frequency compared with the China Telecom and China Unicom, because China Mobile has a lot of user, have enough users, so it need a large frequency band. And this terminal, this frequency band will be used in indoor scenarios. This is China's situation. And end-to-end solution required by 5G is ready. We just it introduced from the chipset to terminal to frequency band, and our system side, our core network is ready, and the access network like the PTN, like the IP RAN or microwave are also ready. This is this device are also ready, and our radio solution are also ready. Radio solutions are ready. Our base station we can provide small cells for some hotspot coverage, small coverage, and the 5G RU may be used for a supplementary uplink. And the super blade site, like the AAU, this equipment used widely. The BBU plus the AAU, BBU plus AAU. In our 4G, BBU 4G BBU plus RRU, remote radio unit plus antenna. But in our 5G and AAU include RU and a antenna. It can support the massive MIMO. And because 5G frequency is high, so using 5G MIMO can greatly enhance the coverage. And in some other scenarios, 5G RU, small cell power side will also be used. So for Huawei company has already this equipment. Huawei, all of this equipment can be provided by the Huawei company, and used for the different scenarios, like in the urban areas, in natural coverage, in a hot spot, having traffic hotspot areas, and the end-to-end production is ready. Under the chapter 4, about the chapter 3, have any question?
No, thank you.
Okay, let's see chapter 4, 5G global commercial development play. 5G commercial development play. And the last chapter, chapter 4, will be the global commercial development play. How is the commercial situation of the world? We can say American, European Union, China, Korea, and Japan. This country has already deployed the 5G. But Japan may be a little slowly. Their networking is still pending. I think in this year, this year will maybe commercial used, And in 5G now, Japan is not the first bench. And the first country which launched the commercial service is the carrier. Carrier is the first operator first country to release the commercial service of 5G. It's in 2019 in the month of April. And carrier launched the commercial service for 5G. And the United States, US, is the second country. Actually, they are almost just the same times. Maybe a carrier is earlier 1 hour than US. Actually, they are just the same, at the same times to release 5G commercial service. And the European Union, such operator also launched the commercial use. Like China, China last year also have launched the commercial use. The first wave application. Focused on the EMBB service, like the HD video, like the VR AR. The first wave, or the HD broadcast. In the first stage, focus on EMBB service. In the early stage of 5G, focus on EMBB large bandwidth service, AR, VR. Maybe in the future, we will wear the VR glass to see the football competition, football broadcast, football football game lively. And we can use the AR. Provide guidance for the engineering cable, and the UAV. We can use the UAV. We call it. We can also call it drone. UAV. And the UAV where in the there is a camera, HD camera, in the UAV, and then this is the 5G antenna, and provide the signal service to this UAV, and provide the HD video backhaul service. And this is the video surveillance. For some police, for some public security. We often use the camera for the video surveillance and the HD video. And all this service need a high throughput. Maybe need 1 giga bps, 1 giga bps. So in the first stage, focus on eMBB, and this is our HD video, HD video. And the next, the second stage may focus on URLLC or MMTC, like the IOV. IOV means the Internet to Vehicle, and the smart manufacturing, and the network jaw, and the network robot. This service need the URLLC, like the MMTC service. So this is you can see in the early stage focus on eMBB, and for this time URLLC, and maybe in 2023 to 25 focus on MMTC. Now in China, the Huawei company has explored URLLC service, like in the port. I have said in the port, if we want to control the machine, like AGV, and some vehicle, we can deploy the 5G network. 5G network, like in our Ningbo port, Huawei also have deployed the 5G network. And according to the report, it has a good effect. And maybe in the future, we are focused on MMTC. Used in a smart seating, use the smart parking, and so on, This is a global 5G commercial play.
Excuse me, I have a question.
Please.
What is UAV?
UAV is drone, actually. Drone. We can use this UAV for the HD video backhaul. Drone. Drone. D-R-O-N-E. Clearly, I can show a small video. I can show you a small video.
Maybe UAV represent unmanned air video.
This one.
5G 无人机解决方案包括自动驾驶飞行器、智慧城市指挥调度中心、行业应用网联无人机、无人机自动化集群编队、巡检、安防、物流配送等。广东联通 5G 作为最新一代蜂窝移动通信技术，是数字天空的最佳通信技术。
Yeah, this is the UAV. Actually, it's we can also call it drone, D-R-O-N-E. We can use this UAV provide the HD video backhaul function, and for the security for the monitoring in the city. Yeah. Clearly about the UAV.
Yes, thank you.
Okay, this is a 5G global training plane, commercial plane. It's a commercial plane. Next, our 5G is focused on the vertical industry, and our 4G focus on the consumer customers. But for our 5G, we focus on the vertical industry. Of 5G will enable the vertical industry. Like the smart grid. I have said why we need a 5G in the smart grid. Actually, we can in smart grid, we can deploy the 5G for the remote control to the video backhaul and a large connection. And this solution will introduce later. Our smart grid is very important for us. If we have no electrical and we may affect our life, and the network requirement need a delay 5 to 15 milliseconds. 5 to 15 milliseconds. If the delay is too large, we may can't control the machine immediately, and the reliability is very high. And the next, the UAV, Joe, I can say the UAV will be deployed the camera, and the camera can backhaul HD video used for public security, agriculture, and forestry. And the delay need 10 to 13 milliseconds, and the reliability is high. And the smart health care, remote surgeon, in China, in Wuhan, when the COVID-19 is spread in China, and we need a lot of hospital. So the government built a new hospital, Hoshenshan and Leisenshan, and so they need the internet network service. But the fiber, it's very slower. But our 5G base station is very quickly. We just need one base station, antenna, and power. It can provide network service. And the 5G, the bandwidth is very, very large. It can provide the HD video service or the sound service. And third, first is a smarter manufacturing. You can robot can control the robot remotely, and also need a delay. So 5G will enable the vertical industry. Okay, I will make a summary. Three main scenarios of 5G service. One is ENBB, one is URL. Please.
Can you? This slide. In 5G, we have, in terms of the latency, achieving low latency, the research is well investigated. Whereas in terms of the reliability, it's still in its fancy stage. So can you tell us what does it mean? How you define the very high, ultra high? Like companies and researchers, they focus on the 3.9 or 5.9 reliability, like, or 2.9 reliability, 0.99, 0.999, or 5.9 reliability. So first, my question, very high. So very high, is it 2.9, 3.9, 5.9, ultra high? How you interpret like fuzzy words, very high, ultra high, to the values of reliability? This is the first question.
Very high, our target, the reliability need to reach the 5.9. No, 5.9. Reliability. This is the target. The target 5.9. So
this is considered as an ultra high. Is that right?
Ultra high.
Yeah.
Yeah, is our target.
Mm-hmm. So how you actually 5.9 is considered as ultra high. The 3.9 it's, we can say, very high, yeah. But how we can, in terms of because we have access network, like RAN, radio access network, and also we have core, and also the cloud. So we have three, like we can consider 3 layers of the 3-layer architecture of the cellular infrastructure, whether we have 4G or 5G. So for core network, achieving reliability is not difficult, because in the core network we have wire line connection and communication within the core network. Like I'm saying that mobile core network. So how about the RAN? So how we can achieve reliability in the radio access? I mean the physical and MAC layer of the 5G. How we can also, is there any technique to achieve what we say ultra reliable communication at the RAN site, radio access network?
The reliability actually in the air interface, in the IP transmission, in the core network, and in the in the IP transmission, we use the FlexE. We use the slice, the end-to-end slice. Make sure the network or service reliability. In our current work, based on the cloud, and in the air interface, I'm not sure. Maybe use the cloud air. Cloud air may make sure reliability. It's just my opinion. My opinion. Yeah.
Okay, thank you.
Actually, you know, URLLC, this protocol, just frozen, not very longer. So after release 16, this protocol frozen, and I think the company or Huawei company will do more practice to check how to make the reliability. Yeah. Now it's at the beginning. Yes. Okay. Have any question?
Thank you. Thank you.
Thank you. Thank you very much.
Okay. Next, the second material. Okay. Next, we will start the second material or 5G network architecture and key technology. Let's see forward. In this course, we will discuss about the key capabilities of the 5G network, and the second to meet this key capability. What are the changes in our 5G network architecture and the air interface? What the key technologies are introduced? So why we can 5G can reach the 10 Gbps ping rate? Why can 5G can realize the 1 millisecond end-to-end delay latency? So compared with our 4G, the 5G's architecture, how the 5G's architecture changed, and what's the key technology that are introduced? Okay, let's see in detail. And I think this picture, I think is I think everyone is similar. The three typical vision. One is ENBB. Another is UILC. Another last one is MMTC. MMTC. This is the ITU's vision. ITU's target for the 5G. On the right side is the comparison between the 5G between the 5G and 4G. IMT advanced is the 4G. It's 4G. 4G. This is the official name. 4G. 4G. And the dark color, this color is 4G. This dark is 4G. This dark color is 4G. And the light yellow color is data for 5G. And the light color, and we compare them in 8 dimensions. These dimensions are just for throughput. The ping rate, and the user experience rate, and the spectral efficiency, and the mobility. These 8 dimensions. And for 5G, our mobility can achieve the 500 kilometer per hour. But for our 4G, just can support 350 kilometer per hour. It's much more enhanced. And for delay, for a 5G is 1 million second, 1 million second, 1 million second. But for 5G, maybe 20 million second, 30 million second to 50 million second, 15 million second, 15 million second. For the connection, we hope to have a 1 million, 1 million, 1 million, 1 million, 1 million devices per kilometer square, and our power consumption efficiency. I want to have 100 times enhancement, and the traffic capability, want to have 10 Mbps. There are comparison between the 4G and the 5G. And you can see all dimensions, the parameters are much more enhanced to realize this purpose. So we need to do some adjustment, need to adjust our architecture, our new technology, and so on and so on. And this is the important highlight on 5G. Actually, it's similar to last page. And the key point is the slicing. You know, our 4G don't have slicing. The slicing means our physical network can be diverted, can be cut into several slice 1, slice 2, slice 1, slice 2, to provide the service to the provide the different service to the different user. And new architecture, and new technology. I also introduced like the new waveform, new more knowledge, and so on. So next, we can introduce the one by one.
Excuse me.
Please.
Excuse me. So I think regarding to slicing in 5G, I think the network have been like classified into 3 different parts. I think the first 2 part has been assigned for the smartphone and high browsing issue, and I think that the second one it has been allocated for the automotive and high reliability thing, and I think the third one is for IoT devices. So it's a network slicing have been divided, as you say, to several parts. Am I right, or if I'm wrong, please correct me?
Yes. Slicing.
That's right.
Yes. Slicing means yes. Slicing means for example, the slicing one, in the air interface, in the IP transmission, in the core network, we will locate a special ID. ID. For example, ID1, ID2, ID2 for the different service. For example, this slicing used for IoT. Okay, let's ID is ID3, ID2. And this ID's resource, ID resource will used for the IoT. And if you use the EMBB service, okay, ID3, this resource used for the EMBB service, and this resource is fixed for this service and kind of short, yeah.
Yes, thank you.
So it can make a good service.
I just want to add something. Even within slices, you have like something like subslice.
Yeah.
For example, you have in one slice. For example, I want to subscribe for a plan in, for example, China Mobile. So China Mobile, for example, they have one slice just for EMBB. So, and they have sub slices within this slice for example, you need gold plan, you need bronze plan or other plans. So and within the slice you have like there's one thing which is called named data network. So in named data network, so for example, when you subscribe for gold plan, which is for example high data rate, so NDN, this one NDN1 under slice 1, NDN2 under slice 2, slice 1, sorry, NDN3 under slice 1 again. So like, you know, hard slice and soft slice. So this is just, you know, I wanted to give some clarification on this. Yeah. Thank you.
Okay. Hard slide and soft slide. Actually, in our 4G, in our 4G, QoS, QoS. QoS in our 4G. QoS just the quality of the service is 4G is the child-based network. It can share the network resource. I think it is the soft slice.
Yeah, sure.
But our 5G, and I will introduce it use the FlexE and use the cloud, and it's a hard slice, and the slice can be insured, can have a physical, a hard slicing for the special service. If user one pay the money to operator, they just want slicing one for the URLC, and this network must be can make sure the network is good. So in the future, and operator will make money through the slice, by the slice. Yeah. Clearly or not?
Yeah, it's perfect.
Yeah, thank you. Yeah. Okay, any question?
Hi.
Hi, please.
I have a question. And when you're saying the slicing, it is the same as beamforming technology, or is it not?
Reforming.
Yeah, slicing is the same as beamforming technology.
Slicing is the end-to-end concept. is end-to-end concept. From air interface to the IP transmission to the core network is a end-to-end concept. Yeah.
So it is like a different thing.
Yeah.
Okay, thank you.
Yeah, it's an end-to-end concept. Okay, and next, the 5G network architecture and key technologies. Actually, next contents will introduce some about how the 5G can achieve the slicing. How the 5G can achieve the low latency or MMTC, and I think tomorrow we will start this part content. Okay, and today content is finished and its time is up. And okay, have any question?
Actually, I had just last question. Sorry, I think network slicing. The SDN will manage the essential, architecture to use and manage traffic. I mean, in another word, I have to say the SDN is responsible to managing the traffic through the whole application program related to the slicing network in 5G. Yes.
Yeah, you mean a software-defined network?
Software-defined network, yes.
Yeah, SDN is one key technology to achieve the how to say that also achieve the resource fully utilized. The control plane and the user plane separated. Yeah, and it can control the IP transmission resource. Yeah, and is one technology to achieve the slice. And another is the NFV, network function virtualization. It's used in core network. Yeah.
Yes, thank you.
So thank it's based on cloud. Based on cloud. Yeah.
And I think if you remember, you mentioned about EMBB and URLL and MMTC. I think like each of these level they have like a special data center. Yes, like it's a core CP or core data center.
Actually, maybe in the future, if we want to achieve the slicing, some customers maybe deploy their data center in their all campus, in their all gardens. So maybe you are right. Different EMPP service have different data center. Yeah.
Yes. Thank you.
Yeah.
Thanks.
Actually, it also depends on the service. If some customers pay attention to the security, so they want to the data center in their all campus. But some service, some customers didn't care about the service. They may care about the investment. They may use the operator's data center. They don't want to pay money to build up the new data center. Yeah. Okay. Time is up, and today's course is finished. See you tomorrow.
Okay. Thank you very much.